Hello and welcome. Today, we're diving into Earth's frozen realm, the cryosphere. This includes glaciers, ice sheets, permafrost, snow, and ice on seas, lakes, and rivers. Think of it as the planet's natural air conditioning system. Why does this frozen world matter so much? Primarily, its bright white surfaces reflect sunlight back into space, cooling the Earth. This is called the albedo effect. The cryosphere also locks up enormous amounts of fresh water. If the ice sheets of Greenland and Antarctica melted completely, global sea levels could rise by a staggering 65 meters. These icy regions aren't static. Glaciers and ice sheets constantly flow, driven by snowfall accumulating and ice melting or breaking off as icebergs. The massive ice sheets in Greenland and Antarctica hold most of our fresh water and react slowly, while the world's over 215,000 smaller glaciers respond much faster to climate changes, often within years or decades. Then there's permafrost, ground frozen for at least 2 years straight, mainly in Arctic and high mountain areas. It holds vast amounts of ancient organic carbon. Unfortunately, our warming planet is causing rapid changes. Glaciers and ice sheets are melting at an accelerating pace. This meltwater is a major driver of sea level rise, currently contributing over a millimeter per year. A big worry is warming oceans melting Antarctic ice shelves from below. These shelves act like dams, holding back glaciers. When they weaken or collapse, glaciers can surge into the sea much faster. This is particularly concerning in places like West Antarctica, home to the Thwaites Glacier. Permafrost is also thawing. This destabilizes land, impacting infrastructure and ecosystems. Critically, thawing releases trapped carbon as CO2 and methane, greenhouse gases that cause more warming, creating a dangerous feedback loop. This permafrost carbon release could significantly amplify global warming. How do we know all this? Scientists use incredible technology. Satellites monitor changes in ice height, mass, and speed from space, using radar, lasers, and gravity measurements. We track sea ice extent, snow cover, and glacier boundaries. On the ground, researchers measure snow and ice directly, track ice movement with GPS, measure ice thickness with radar, and monitor permafrost temperatures using boreholes. Computer models help us understand past changes and predict the future. The shrinking cryosphere has global consequences. Rising sea levels threaten coastal areas. Billions rely on glacier melt for fresh water. Shrinking glaciers endanger water supplies for drinking, farming, and power, especially in regions like high mountain Asia. Losing ice and snow cover means Earth absorbs more heat, accelerating warming. Thawing permafrost can trigger landslides and release more greenhouse gases. This isn't a distant problem. Recent reports show alarming speed. Record low sea ice and massive glacier melt underscore the urgency. We need continued monitoring, better models, and, most importantly, deep cuts in global greenhouse gas emissions to lessen the impacts of this critical planetary system in decline. Thanks for tuning in.